You press a button, the light turns on. Cause, then effect. This is how reality works, everywhere, except in certain regions of spacetime where the universe has a glitch. Places where the effect happens before the cause, where you could theoretically die before the bullet is fired. These regions actually exist, and physics can prove it. In 1949, mathematician Kurt Gödel discovered something that made Einstein deeply uncomfortable. He found a solution to Einstein's own equations, a universe where time travel to the past wasn't just possible, it was built into the fabric of space-time itself. But here's what's terrifying. Gödel wasn't talking about science fiction. He was talking about closed timelike curves, actual paths through space-time where cause and effect become a loop, where the future reaches back and touches the past. And we've found these regions. They're called causality-violating zones, and they break the most fundamental rule of existence, that causes must come before effects. Let's start with the most accessible example, the ergosphere of a rotating black hole. When a black hole spins, it drags space-time around it like a whirlpool. Just outside the event horizon is a region called the ergosphere, a place where space-time itself is rotating so violently that staying still becomes impossible. Inside the ergosphere, light cones, the paths that define your possible futures, tip over. They tilt so far that some of your potential futures point backwards in time. If you entered this region with enough precision, you could theoretically complete a closed time-like curve. You'd emerge from the black hole before you entered it. The effect precedes the cause. You become your own grandfather paradox. Then there are traversable wormholes, not the Hollywood kind, the theoretical kind that emerge from Einstein's field equations. If you had two wormhole mouths and accelerated one near light speed while keeping the other stationary, time dilation would cause them to age differently. The moving mouth would experience less time. Now connect them. You'd create a shortcut not just through space, but through time itself. Enter the younger mouth, exit the older one, and you'd arrive before you left. Physicist Kip Thorne proved this mathematically. The problem? We'd need exotic matter with negative energy density to keep the wormhole open, and we don't know if that exists. Here's where it gets stranger. In 1974, Frank Tipler proposed the Tipler Cylinder, an infinitely long, incredibly dense cylinder rotating at near light speed. If you flew a spaceship in a spiral around this cylinder, the frame dragging effect would be so extreme that your path through spacetime would curve back on itself. You'd complete a closed time-like curve and arrive at your starting point before you left. The catch is it requires infinite length and impossible density. But mathematically, it works. The universe allows it. What disturbs physicists isn't that it's impossible to build, it's that the laws of physics don't forbid it. In 2014, researchers at the University of Queensland created a simulation of a photon traveling through a closed time-like curve using quantum mechanics. The result? The photon could interact with its past self. Cause and effect became entangled in a quantum loop. This wasn't time travel in the traditional sense, it was causality violation at the quantum level, and it worked within the known laws of physics. Even more disturbing, some interpretations of quantum mechanics suggest these causality loops might be happening constantly at the Planck scale, the smallest possible scale of space-time. Reality might be glitching trillions of times per second, and we'd never notice. Stephen Hawking was so disturbed by these causality-violating solutions that he proposed the chronology protection conjecture, the idea that the laws of physics conspire to prevent time travel and causality violations. Whenever you try to create a closed time-like curve, quantum effects or energy requirements become infinite. The universe protects its own timeline. But here's the problem. We don't have proof. The conjecture remains unproven, which means the universe might not have a defense mechanism. These regions might be possible. They might even exist naturally in extreme gravitational environments we haven't discovered yet. And if they do exist, then somewhere in the universe, cause and effect are reversed. So what does this mean for reality? It means the arrow of time, the idea that past leads to future, might not be universal. It might just be local, a consequence of our corner of space-time, not a fundamental law. In certain regions, the future could influence the past. Effects could precede causes. The universe could contain closed causal loops where events create themselves. We live in a universe with glitches, regions where the code breaks down, where the fundamental order of existence becomes negotiable. And the most disturbing part? We don't know if we're in one of those regions right now. We don't know if the cause of this moment is still in our future.